The rapid development of artificial intelligence, AI, has benefited from large-scale training data in real-world application. As AI becomes increasingly ubiquitous, nations are increasingly concerned about AI governance and privacy protection. They instituted new legislation such as the General Data Protection Regulation, GDPR, for these purposes. These new laws can potentially limit the development of AI in the long run. Federated learning, in which training happens where data are stored and only model parameters leave the data silos, can help AI thrive in the privacy-sensitive regulatory environment. It involves self-interested owners of potentially sensitive local datasets collaboratively training machine learning models. In this way, end users can become co-creators of future AI solutions. Today's federated model training paradigm is based on an important assumption. After federated model training, all participants receive the same final model regardless of their contributions. This assumption may pose challenges to the adoption of federated learning, especially under the business-to-business settings. Suppose banks A, B and C want to collaboratively train a model to predict the creditworthiness of small and medium enterprises in a privacy-preserving manner. Bank A is significantly larger than B and C. If all of them receive the same final model under the current federated learning paradigm, Bank A, which can contribute more to building a high-quality model, may hesitate for fear of benefiting other smaller banks and eroding its own market share. Is there any way we can improve the current federated learning paradigm to ensure a fair treatment of the participants and sustain healthy collaboration? In this video, we present our solution to address this challenge, the Fair and Privacy-Preserving Deep Learning Approach, or FPDL. Unlike existing works which use money as incentives in federated learning, it uses the final model to incentivize collaborative behaviors. Specifically, federated learning participants will each receive a final model with performance reflecting their individual contribution to the federation. This is how it works. Firstly, each participant decides the level it wishes to contribute to a given federation. Then, it assesses the quality of the local training data of other participants in the collaboration network via mutual evaluation without looking at the raw data. Through such a process, each participant builds up a record of the individual local credibility scores of others, which represents how much it can trust the others in each collaborative training round. At the end, each participant uses the local credibility scores to help it decide with which other participants it should form federated model training pairs. Over different rounds of interactions based on mutual trust, each participant will gradually build up its own federated deep model which reflects how its peers value its contribution. Following this new federated learning paradigm, communities of data owners can self-organize in open and dynamic federations through establishing trust-based collaboration networks to train deep models. In the future, we can build up a federated model crowdsourcing platform based on this paradigm to bring the AI gig economy into reality. Thank you.